A function is a block of code which only runs when it is called. A function can return data as a result. A function helps avoid code repetition. We'll discuss this more in a bit, but first, let's explore how we can create functions. In Python, a function is defined using the def keyword, followed by a function name, for example, my_function, followed by parentheses and a colon. Now, within the function, we have to indent, and we call this within the function a scope of the function. But within the function here, we can, for example, print a statement like call from function. This creates a function that prints call from function when called. Now, of course, when we run the program, nothing is going to happen. We don't see anything here in the output. That's because we actually need to call the function. To call the function, we simply write its name followed by parentheses outside of the scope of the function. So here, I can just say my function, parentheses, and run the program. Now we get call from function. And we can call this function multiple times. It will print the same statement over and over again, depending on how many times it was called. Notice when I name the function, the naming standard is similar to that of naming variables. A function name must start with a letter or underscore. In this case, we started with a letter M. We can also just simply start it with an underscore. And this works as well. We cannot start a function with a number. For example, I cannot say like 12. When I run the program, I would get an error in this case. We also cannot have spaces in the function name. For example, I cannot say my space function because we would get an error. We can have numbers in the function name as long as it's not at the beginning. For example, I can say my function1, and this works fine. By the way, functions are case sensitive in Python. So if, for example, I had this f over here as a capital F, and I'm calling this function here with a lowercase f, and I run the program, it's not going to be recognized. By the way, though it's not a strict rule, keep in mind that it's a good practice to use descriptive names that explain what the function does, just like we do for variables. For example, if you are adding numbers between each other, in other words, summing numbers, we can create a function like calculate sum, and this way, someone looking just simply at the function name would be able to tell what this function purpose is. In this case, it would be like summing numbers. Earlier, I mentioned that functions help us avoid code repetition. Imagine we need to convert temperatures from Fahrenheit to Celsius several times in the program just like this. Without functions, we would have to write the same calculations repeatedly. With functions, we can avoid this and create reusable code instead. For example, we can create a function called Fahrenheit to Celsius, and this function can take in what we call a parameter, more on that later, but the parameter could be the Fahrenheit, and within the scope of the function, this is where we would have what we call a return statement, and we would return the conversion calculation between Fahrenheit to Celsius. So the formula for that would be Fahrenheit minus 32 times 5 divided by 9. So now that we have the function created, we can now simply call the function through the print statements, and we pass in the data value of the Fahrenheit that we want to convert to Celsius. For example, 77 would give us 25 degrees in Celsius. And we could do this over and over again with different values using the same function. When a function reaches a return statement, it stops executing and sends a result back. So for example, we can have a function that returns a value, def get greeting, return hello from function, and create a variable like message and set it to the call of the function, get greeting. Now we print message, and when we run the program, we will get the return value from the function. Now, instead of setting the function call to variable like message, we can actually just use the return value directly through the print statement. So print get greeting, run the program, and here we get hello from function. By the way, if we remove this statement here, in other words, we did not have a return statement, we just had return, what we would get when we run the program is none, which is basically like nothing. Now, if we did remove the return, and we did not have anything in the scope of the function here, then what we would get is an error. So we must have something, But what if you were in a situation where you were maybe designing and implementing your code still, and you still don't have an idea of what the structure is completely yet? So you are still defining the structure first and plan to implement the details later. So what can you do in that case if you don't want to have a return or anything just yet? Well, we can have a pass statement. Now when we run the program, we won't get an error. So this is similar to conditionals, where if we needed to create the function as a placeholder without any code, we can use the pass statement. Now, we've seen in the previous example, converting from Fahrenheit to Celsius temperature, we were passing what I called a parameter here in the parentheses of the function. So we call this also an argument of a function. Let's talk more about this. Arguments are specified after the function name inside the parentheses. For example, a function with one argument might look like my function, parentheses, maybe first name, fname, and perhaps this function can print the first name plus Williams. So now when we call the function, we pass here the argument, which is basically a string or a text that we're expecting here. And the text that we're expecting is the first name of a person. Maybe we can say Emil. And when we run the program, we get Emil, which essentially what's happening here is it's substituting the value provided by us, the user, and substituting it with the parameter or the argument of the first name with the actual value. So Emil. And then what happens is in the print statement here inside the function, it says, okay, fname is now Emil, the value passed by the user when we are calling the function, and then concatenate to it some other string as well. In this case, maybe like a last name, Williams, and we get Emil Williams when the function is called. And of course, we can try this with multiple other first names like Tobias. So here we get another call Tobias Williams, and so forth. Now the terms parameter and argument can be used for the same thing. It's basically information that are passed into a function. From a function's perspective, a parameter is the variable listed inside the parentheses, like in this case fname, while an argument is the actual value that is sent to the function when it is called, for example, like Emil or Tobias here. Now, by default, a function must be called with the correct number of arguments. For example, suppose that instead of this hard-coded Williams text here that would be considered like a last name, we can change it to another parameter for the function definition next to the fname by saying fname comma lname for last name, and then here we can replace the hard-coded text with lname. So now when the function returns the print statement, it's gonna basically say, okay, the first name argument plus the last name argument sent in by the user. Now in the function call here, we need to specify the same exact number of arguments. So now that we have a last name, we need to say, okay, Emil comma last name Williams, for example. And I can put some space here a little bit before it so that it can be readable. And I would say the same thing for Tobias Williams. Now when we run the program, we will get a similar output like we had before, Emil Williams and Tobias Williams. So in this case, the function expects 2 arguments, and therefore we need to pass in exactly 2 arguments. If I try to pass in only 1 argument, for example, like the first name, when we run the program, we're going to get an error. My function missing 1 required positional argument, lname. Now, what if you don't want to specify another argument here, like the last name, and still somehow want the code to work? Well, there is a workaround, and you can actually specify a default value. For example, for the lname parameter, I can specify a default value like Williams. Now, when the function here is called without a specified last name argument, then the default will kick in and take its place. So when we run the program, now the program works. So even though we did not specify a second argument here in the function call with Emil, the default has taken place for the last name, so now it works fine. In addition to the requirement of the number of arguments matching, unless you have a default value in the function's parameters, there's another requirement where the order should match the order of parameters. So the order of the arguments here, where you are specifying the value, should match the order of the parameters. Otherwise, if I said Williams here and Emil next, now if the Emil was the first name, then you would get Williams Emil, so last name, first name, but technically speaking, someone might think Williams might be the first name, even though you intend it to be the last name. So you can see the ordering can matter. Is there a way for us to bypass this dilemma here where we can retain Williams, for example, as the last name and then followed by the first name as the arguments of the function, while in the output we would get Emil Williams? There is. And what we could do for that is we can specify a key and value syntax. So for example, we can say lname equals Williams, fname equals Emil. So now when we run the program, we will get Emil Williams, even though the last name was specified first, followed by the first name as the arguments of the function call. So this way, with keyword arguments, the order of the arguments does not matter. By the way, when we say keyword arguments, it's often shortened in Python documentation as KWargs. Now here, we are not using keyword arguments, so we are using direct arguments. In other words, we are preserving the order of the arguments, first name and last name, directly with values, no keys. In this case, we call this positional arguments, and with positional arguments, ordering matters. Now, what if we want to restrict the function to only allow positional arguments? So no keyword arguments like this. Well, what we can do is we can specify here a comma and a slash. So the slash after all the function parameters. Now, when we run the program, we will get an error. My function got some positional only arguments passed as keyword arguments. So it's referring to this one here. If I comment this one out and I run the program again, it runs just fine because in this case, the Tobias Williams call, we are not using any keyword arguments or kwargs, only positional arguments. Now, what if we want to do the opposite? So instead of allowing positional arguments, we want to allow only keyword arguments or kwargs. So for that, we can remove the comma slash here and we can put at the beginning of the function definition, so before the parameters, asterisk or star, comma. Now, this basically says only keyword arguments are allowed, not positional arguments. So when we run the program, we will now get Emil Williams printed out from the keyword arguments call. But now when we have the positional argument function call, we get an error for it. My function takes 0 positional arguments, but 2 were given. Now we can actually combine both argument types, so both positional only arguments and keyword only arguments in the same function. For example, this function basically calculates the sum of 4 numbers and returns 50 in this case, because 5 plus 10 plus 15 plus 20 is 50. So let's demonstrate how we can have both positional and keyword arguments. What we could do in this case is we could, for example, after the B, we can insert a slash, comma, and then we can insert an asterisk, comma. So now here, instead of the 15 being just a positional argument, we can actually make it a keyword argument. So we can say, for example, C equals 15. Now we can say for the 20, D equals to 20. Now when we run the program, we get 50 as well. So the same result. And what this is basically saying here is the arguments before the slash, in other words, the A and B, which is the 5 and 10, are positional only. So we cannot say, for example, A equals 5. We would get an error. And then we're saying the arguments or the parameters after the star or the asterisk are keyword only arguments. So in other words, I cannot say for this one here, the 15, I cannot just say 15. If I run the program, I would get an error. So in other words, the 15 must be a keyword argument. We can send any data type as an argument to a function: strings, numbers, lists, dictionaries, etc. The data type will be preserved inside the function. For example, we can send a list as an argument. Run the program, and we get apple, banana, and cherry. So here we are sending a list of fruits as an argument into this function. We can even send a dictionary as an argument. For example, here we have a myPerson dictionary, which contains a name key followed by the Emil value, an age key followed by 25 as the age of Emil in this case. So when we run the program, we can see that the myPerson dictionary was passed in as an argument to my function, and then the values were substituted accordingly. So here we accessed the name key in the dictionary of person, and we accessed the H key in, again, the dictionary of person that was passed in as the argument through the myPerson dictionary here. And we can see that we get name is Emil and age is 25, which is coming here from the print statements in the my function. Now let's talk about scope. A variable is only available from inside the region it is created. This is called scope. There's different types of scopes. We'll start talking about local scope. A variable created inside the function belongs to the local scope of that function and can only be used inside that function. For example, if we have function, my function, with a variable x set to say 300, and we are printing that variable and calling the function, in this case, the variable x is locally scoped to my function, meaning that this variable is only available to my function. So for example, if I tried printing the variable x outside the function, standalone like this, print x, and I run the program, I'm going to get an error. Name x is not defined. So in other words, x is only available to my function. By the way, in Python, we can actually have a function inside the function. And when we do that, the local scoped variable can actually be accessed by those inner functions. So for example, I can have a function here, def my inner function. And now we can make the print statement as part of this my inner function. And then we can call my inner function inside my function. So now when my function is called and run the program, we will get 300. So x was called from within my inner function, which is inside my function, and the locally scoped variable x is available to any of those inner functions inside my function. Now suppose this x equals 300 was actually outside of the function my function. We call this global scoping. So this means x is available to the entire Python code because it's not scoped within a particular function. In this case, if I was to print x outside here and run the program, we will get 300 printed out twice because it's being called through this inner function here, and my function is calling upon that, so we get it printed at least once from there. And then it's also getting printed from this line 11 over here, print x, which is using the value from the global scoped x variable inside the print statement. So it's printing it here. So in other words, globally scoped variables can be used by anyone inside the Python code. Now, what if I defined x also inside the function here? So x equals 200, for example. Well, we have two variables of the same name in the Python code here, but because this x is locally scoped to my function, so Python will treat them as two separate variables, one available in the global scope, meaning outside the function, and one available in the local scope, meaning inside the function. In this case, the function will print the local x variable, and then the code will print the global x variable. Now, if for whatever reason you need to create a global variable but are stuck in the local scope, you can use the global keyword. For example, here in my function, I can specify global x and set x to say 300. So in this case, if we are using the global keyword, the variable belongs to the global scope, even though the x here is within my function. When we run the program, we get 300 and 300. So the print x line here was able to recognize x as a global variable, even though it was inside my function using the global keyword. Now suppose that we had defined the variable x globally as well here, and for some reason, maybe we changed the variable inside the function to a different value like 200. Now, technically speaking, both of these variables are global. So what happens in this case? Well, what will happen is, because we have the global x here inside the function, this will override the value of the other global variable x. So in this case, we will get 200 printed out for both my function call and the print x here. Now we also have something called non-local keyword. The non-local keyword is used to work with variables inside nested functions. In this case, my inner function is nested within the my function. So for example, here I have x equals 200. So within the nested function, if I had non-local x and I set this x to some other value, like let's say 100, now what will happen is the non-local keyword will make the variable belong to the outer function. So when we run the program, we're going to get 100, even though this x right here is set to 200. Now let's talk about Lambda functions. A Lambda function is a small anonymous function. A Lambda function can take any number of arguments, but can only have one expression. The syntax for a Lambda function is you have the Lambda arguments, colon, followed by the expression. The expression is executed and the result is returned. For example, I can say x equals lambda a colon a plus 10. In this case, we are adding 10 to the argument, which is a, and returning the result. So we can print x and pass the argument 5. So now what will happen is 5 is being substituted with the a argument or parameter, and then we will get 15. Similar to regular functions, Lambda functions can take any number of arguments. For example, here I can say after the lambda a, I can say comma b, and then we can say here plus b, and then here we can say 5 and something like 6. So now we will get 5 plus 6 plus 10, and we'll get 21. Although this is a very simple example, the power of Lambda functions is better shown when we use them as anonymous functions inside another function. For example, suppose that we have a function definition that takes one argument, n, and that argument will be multiplied with an unknown number. A. We can use that function definition to make a function that always doubles the number we send in. For example, building on this example, we can specify my doubler equals to my function, takes in, say, 2 as an argument, and then print my doubler, say 11 as the argument. Now, when we run the program, we get 22. So in this case, what's happening is we are passing the 2 inside the lambda A argument. And then after that, with the print statement, we are calling the my doubler variable, which is calling the my function. And then we are passing the 11 through the n here. And then it's basically saying 2 times 11, which is 22. So essentially, use lambda functions when an anonymous function is required for a short period of time. In this case, for the operation of doubling a number. Now let's talk about the Python range function. The built-in range function returns an immutable, meaning a non-modifiable, sequence of numbers commonly used for looping a specific number of times. This set of numbers has its own data type called range. The range function can be called with 1, 2, or 3 arguments using the following syntax: start, stop, and step. The start argument is actually optional, and if not provided, it defaults to 0. If the range function is called with only one argument, the argument represents the stop value. For example, let's create a range of numbers from 0 to 9. To do that, we can say something like x equals range 10. This will return a sequence of each number from 0 to 9. In this case, the start argument is 0, inclusive, and the stop argument is 10, exclusive, meaning 10 would not be included and 0 will be included. Now, if the range function is called with 2 arguments, for example, if I said 3, 10, the first argument, in this case 3, represents the start value, and the second argument, in this case 10, represents the stop value. So this would return a range of numbers from 3 to 9, 3 being inclusive, and 10 being exclusive, meaning 10 not included. Now, if we specify a third argument, like 2, this would represent the step argument. The step value means the difference between each number in the sequence. So even though it's optional, and if not provided, it would default to 1. In this case, what we're saying is return the sequence of each number from 3 to 9 with a step of 2. Ranges are often converted to lists for displaying them. So in this case, I can say list x, run the program, and now we will actually get the range of numbers, 3, 5, 7, and 9. Now notice in this case, the reason why it's skipping 2 is because of the step argument here. If we remove the 2 and only kept it to 2 arguments, the start and the stop, we will get each number from 3 to 9 printed out. And if we remove the start, which is the 3, and run the program, we will get from 0 to 9 printed out, with 10 being exclusive. Like other sequences, ranges can be sliced to extract a subsequence. For example, I can specify here x index 2, and when I run the program, I'm going to get 2. So in this case, we are returning the value at index 2, which is actually 2. Because remember, with this range of 10 here, we are going to be printing out 0, 1, 2, 3, etc. And in this case, 2 in that sequence is actually at the second index. Because remember, indices start from 0, so 0, 1, 2, and indeed 2 is at that second index. We can also return a new range object, say from index 0 to 3, and the way we could slice that is we could specify the slice operator, followed by 3, run the program, and we'll get range from 0 to 3. Now, of course, we can display the actual sequence of numbers by, again, converting the range object to a list, and now if we run the program, we're going to get 0, 1, and 2. So this way, we limited it just from indexes 0 all the way up to 3, with 3 being exclusive. Ranges support membership testing with the in operator. For example, we can check if the number 6 is within this range here. So I can say 6 in x, run the program, and here we can see that 6 is indeed in the range, so we get true. Now if we check is 7 in the range, run the program, we will get false because 7 is not in the range. And it's not in the range because, again, we're using here the step value of 2, so it's skipping by 2, all the way up to 9, and 9 is not included. Ranges support the len function to get the number of elements in the range. So here we get that the length of the range is 5. Now let's talk about a very important concept in computer science known as recursion. Recursion is when a function calls itself. It's kind of like a mirror reflecting another mirror endlessly. It's a common mathematical and programming concept. It has the benefit of meaning that you can loop through data to reach a result. For example, here we have a recursive function call So we have a function called countdown, which counts down a given number as an argument. And if the number is less than or equal to 0, then we will say it's done counting down. But if the number is still greater than 0, then what will happen is we're going to print that number, and then we're going to call the function itself within itself and count down that number by subtracting 1 from it until it reaches 0. In this case, I call the function with the argument 5, and if we run the program, you can see in the output that we started at 5. So this means that in the first function call, what happened is we passed 5 as the argument, and then it said, is 5 less than or equal to 0? It wasn't, so then we skipped to the else block, and then we printed 5, and then we said call the function itself, which is countdown, with the argument 5 minus 1, so then now 5 is 4. So then we called the function itself again, and we said is 4 less than or equal to 0? It's not, so then we skip to the else condition, we printed 4, and now we say 4 minus 1. And again, we call the function itself again. So now 4 becomes 3, and then we print 3, then 3 minus 1, and then again, the same thing, we print 2, and then 2 is still greater than 0, so then 2 minus 1, we get 1, and then we print 1, and then 1 is still greater than 0, so now we get 1 minus 1, and then now we have 0. Is 0 equals to 0? Yes, it is. Then we just print done, and then exit the function call. By the way, you should be very careful with recursion, as it can be quite easy to slip into writing a function which never terminates, or one that uses excess amounts of memory or processor power. But when written correctly, recursion can be a very efficient and mathematically elegant approach to programming. So it has its use cases, but be very careful with it. Now, every recursive function must have two parts, what we call a base case and a recursive case. In this case, the base case would be the condition that stops the recursion. So in this example, this would be the base case, where when n reaches 0, then we print done and exit the function recursion. However, when n is not 0, when it's still greater than 0, then this is the recursive case. Without a base case like this here, the function would call itself forever. For example, if we run the program, we get recursion error, maximum recursion depth exceeded. So in other words, the function would call itself forever, causing what we call a stack overflow error. The Fibonacci sequence is a classic example where each number is the sum of the two preceding ones. The sequence starts with 0 and 1. So 0, 1, 1, 2, 3, 5, 8, 13, etc. The sequence continues indefinitely, with each number being the sum of the two preceding ones. By the way, this Fibonacci sequence is often found in nature, like through fractals, and has very crucial applications. It's even used in project management, like one day if you're working in an organization or in a team that uses agile tools like Jira or Azure DevOps boards, for example. You have something known as epics, features, and stories, and the stories represents the tasks that engineers or programmers would work on, and you can estimate these tasks using the Fibonacci sequence of numbers. Now each team evaluates the sequence of numbers differently. For example, 1 might represent maybe a 1 day worth of work, maybe 3 might represent 2 days worth of work, maybe 5 days might represent a week's worth of work. Now we can use recursion to find a specific number in the Fibonacci sequence. For example, we can create a function called Fibonacci that takes in the number we are trying to find in the sequence, and we can say the base case, if n is less than or equals to 1, then return n. Else, return, and here is where we are going to call the Fibonacci function within itself, Fibonacci, and this represents the Fibonacci formula. So it's n minus 1 plus the Fibonacci of the number minus 2. So it's fib of n minus 1 plus fib of n minus 2. So now, for example, if I want to find the 7th number in the Fibonacci sequence and I run the program, we're going to get 13, which is indeed correct. The 7th number in the Fibonacci sequence is 13. Now, if we did not have the base case, the if n is less than or equals to 1, return n, what will happen is we're going to get a stack overflow, maximum recursion depth exceeded. So the base case is extremely important to avoid running out of memory, for example, because the function called stack is placed on the stack in the RAM memory. So the base case is a safeguard to terminate the recursive call of the function once we have hit the maximum recursion depth.